A bullet of mass 0.02 kilogram traveling at 330 meters per second, and find the wavelength of the bullet. We already know the wavelength. Let me write a wavelength with a WL. So represents a wavelength is equal with a constant Planck constant h divided by momentum. Or wavelength, the momentum we already know is the product of the mass and the speed. So h is equal to the m times v. And now we already have the mass of the bullet, but first of all, let's write here the Planck constant. The Planck constant has a value 6.6 times 10 in minus 34 joule times second. And the mass here of the bullet is 0.02 kilogram, 0.02 kilogram, time the velocity of the bullet is 330 meters per second, or the speed is 330 meters per second. And now let's make this a little bit, let's simplify this equation a little bit. So let's write here 6.6 times 10 in minus 34. And let me convert this to joule. The unit is a kilogram times a meter square over second square. So is a kilogram meter square over second square times second here. And here down we can multiply 0.02 times 330 is 6.6. 6.6 and is a kilogram meter per second. Now what we can do here, we can simplify. We can simplify now kilogram with a kilogram. Square meter with a meter can go here. And 1 second with 1 second can simplify here. Here remains just second, but this second can simplify with the other second. And finally this can be here now. Now wavelength is equal 6.6 divided by 6 is just 1 time, and what remains here remains a 10 in minus 34, and remains just a meter, 1 meter here, just a meter. So the wavelength is 1 times 10 in minus 34 meter, or we can write, finally we can write this way. So the wavelength of the bullet, because it has the nature of the Broglie wavelength, it is a 10 in a minus 34 meter.